Hey guys, so I'm back, and just for this future reference for this contest thing, this is microphone number 6. So, anyway, today we're going to be talking about the AMS detector, which is going to the International Space Station. So, or it's at the International Space Station now. So anyway, AMS stands for Alpha Mass Spectrometer, and so this was made by CERN. As you can say here, it hugely benefited from CERN's resources and expertise because they have the Large Hadron Collider, and CERN is involved in so many scientific things, it's ridiculous. So they have the clean room facilities there, and in fact, I think they're running the center for the AMS is in CRN as well. But yeah, as you can see here, CRN has some vacuum and magnetic groups. But anyway, so the AMS, this is what it does essentially. It's looking for antimatter, because it's a big mystery. Because in the particle colliders, such as the Large Hadron Collider and Tevatron, that when they create matter from energy, they get matter and antimatter in equal parts, and so they're theorizing that in the Big Bang this should have happened as well. But in fact, this didn't happen. From what it looks like, everything around us is matter. So it's looking for whether nature has a preference for matter over antimatter, and it's also looking for the dark matter, because it's a big mystery where the dark matter is, because it says here, quote from somebody, that 95% of our universe is dark matter and dark energy, and we don't really know anything about this. So, it's looking for antimatter. It says here, just one single antinucleus among a billion other particles it can detect, and that's crazy how it can detect that. It's like sending up one of the detectors from the Large Hadron Collider into space. And so what it does is it looks at the flux of cosmic rays. And so what is flux? It's really complicated, and I really don't fully understand it, but from what I can get, it's sort of like a vector of cosmic particles, and a vector is direction along with like the direction of a flow, I guess we can call it, and the rate of the flow, the velocity. So that's sort of what flux is, and so I mean, that's pretty crazy. So it says it might actually discover, if it sees an antiparticle, that will be huge, because then it could show that there were large resources, large sort of anti-universes out there in space that this particle might have come from. And also, if there is a dark matter particle or something like that, then it could detect it indirectly by recording an anomaly in the flux of the cosmic rays. So if they normally have X flux, and then instead they have Y flux, they can say, well, that might be dark matter. So, yeah, and so that is the AMS, stands for Alpha Mass Spectrometer, some new news, and right here we have a video of the space shuttle going up, so I'm just going to play this in full screen so we can see that, and it's going to be a bit of a commentary over it, as none of the audio from the computer will actually get in, or maybe a bit will in the background. But, sorry, HyperCam 2 is making it go a bit slow. But anyway, so it was carried up by the last launch of the space shuttle Endeavour. And so, Endeavour did launch successfully. I'll sort of ruin that for you. But, which is really good. I love when rocket launches go successfully. They've become a lot safer over the years now. But anyway, so, AMS is in the bay right there. I think it is like the biggest or the heaviest or something like that thing that the space shuttle has ever carried up. And so something like that. I think the thing is huge, and they're going to mount it on the International Space Station. I'll get a diagram up in 1 second after this. We see the launch here, but you can see here's a view from the tank. And so it made it up successfully, and I can't wait to see whether there is antimatter or whether the Big Bang needs to be completely reworked to be counted for this loss of antimatter, or whether antimatter has to be reworked to account for this loss of antimatter, or whether both of them have to. So that would be really interesting. But personally, if you want to hear my own opinion, my opinion is that there are no antimatter galaxies. My opinion is that this is kind of controversial, I think. I heard this somewhere, and it seemed pretty reasonable to me, is that there were electron and anti-electron pairs in the empty space, sort of, between all matter. and these electron and anti-electron pairs were constantly annihilating, which produced photons, which then combined back together into anti-electrons and electrons. So I think that might be where the antimatter's sort of gone, I think, from the Big Bang. So the original antimatter from the Big Bang would be long gone by now, but the byproducts of it are still here. So that's what I think. And of dark matter and dark energy, I think there's a lot of dark energy and a lot of dark matter, and dark matter is simply a particle with a different spin or something like that. So that's what I think. But anyway, you've seen enough of this here. We can fast forward. Anyway, the shuttle just left off its internal fuel tanks, and the thing makes it successfully into orbit. So good job, everybody at NASA. Thanks for that. Sorry, the mic was off. I feel like an idiot. Okay, I was saying that coming back to here to wrap this up, we got the AMS detector successfully launched into space. You can see here. So it's looking for antimatter and dark energy to see where they are, some of their properties. Right here says the cosmos is the ultimate laboratory. Pretty true. Anything can happen there. And for particle physics, it's just like seeing the same stuff essentially in a different place. So you can see this stuff in the Large Hadron Collider in your own laboratory, but to see how it actually works in space is just something unbelievable. So good job to everybody at NASA and around the world who made something like this possible, and good luck to the AMS. Thank you. Sorry for the short sound outage. Go to my watch my other YouTube videos in the series, subscribe, comment, rate this video, go to my website, quicknuclearscience.webs.com. If you don't have a YouTube channel, you can still comment there if you put in your email, so do that. All these videos in the series get uploaded there. Again, thank you so much for watching, and good luck to the AMS. I hope it discovers everything and something new. Like, it's not just looking for matter to antimatter and dark matter. It's looking for anything new. So I hope something really cool, really new, never thought of comes out, because I generally like to make statements like this. I generally like to support the extremely new, unviable thing. So yeah, but thank you for watching.